All right. Hi, everyone. Welcome again to Tariga Engineering Solutions. We accompany you for your civil engineering journey. So in this video, this will be the part 2 for our fluid mechanics, steel be properties of fluids. So if you haven't seen the part 1, I will just put the link below or somewhere your screen. No? Okay, in this video, I will be discussing more, focusing about the ideal gas law. So not in the sense thermodynamic approach, but that is relative only lang for fluid mechanics, which is syempre most of the times isothermal state. Okay, so without any further ado, let's start with this part 2 of properties of fluids. Okay, ideal gas equation. So your ideal gas equation, maybe you are familiar with this sa thermodynamics ninyo. Well, actually, meron talaga silang similarity or actually ito talaga, no? Because somehow yung sa fluids, we also consider yung gas, but not gas na gases talaga, specifically yung air lang, no? Yung air. Air is a gas, right? Okay. So the formula for ideal gas equation is equal to PV is equal to MRT. So what is PV, MR, and T? P is the absolute pressure from the word absolute. So, dapat absolute yun na siya, no? Let me underline that one. Absolute. So, dapat absolute yun. Kasi merong gauge, merong atmospheric pressure. There's a difference. So, the unit of that, syempre pressure, kilopascal, megapascal, or PSI stands for pound per square inch. Yung V naman is the volume in cubic meters, cubic centimeter, or cubic feet. Yung M naman is the amount of substance. That would be thermodynamic term. But in fluids, M is the mass. No, that is self-explanatory. Amount of substance is the mass. Okay, so pwede kilogram, gram, slag, or pound. Okay, yung R naman is the gas constant. These are the units that is applicable. No, gas constant. And yung T naman, remember, that is absolute temperature. So, degree Kelvin or degree Rankine. Not just degree Celsius or degree Fahrenheit. Again, degree Kelvin or degree Rankine. So next, ito yun, no? For absolute temperature, how do we convert degree Celsius into Kelvin and degree Fahrenheit into Rankine? So there is a relationship also or sort of formula. For SI units, so sa SI, Kelvin man yan. So for degree Kelvin is degree Celsius plus 273. Well, actually, exactly 273.15, but okay na yung 273 approximately. For English units, we use degree Rankine, which is degree Fahrenheit plus 460. Okay? So, please remember this conversion. Okay? So, hindi ko na lang pinakita yung how to convert degree Celsius and degree Rankine, degree Fahrenheit, I guess. I mean, no? Because if hindi natin alam, nasa calcu yan, no? Nasa calcu. But anyway, let's just move on to the next part. So from that ideal gas equation, we can form the gas density. We all know that, let me clear this one first now. Okay, for gas density, or the density is the ratio of mass per unit volume. So if you will rearrange this ideal gas equation, you will get M over V is equal to P over RT. Okay, do not mistaken the rho at saka yung P. Rho is the density, P is the absolute pressure. So ito yung formula for gas density. Now we will talk about the combined gas law. So combined gas law is derived or came up with Avogadro, no? If I'm not mistaken, kalimutan ko. Kay Avogadro ni siya. The combined gas law states that the volume of a given amount of gas is proportional to the ratio of its Kelvin temperature and its pressure. Well, actually, this is not Kelvin temperature, this is absolute temperature. So sabi daw, ang volume is proportional, or rather, ito, mathematically stated. So yung volume is proportional to temperature over the pressure. So meaning, yung volume is directly proportional to the temperature and inversely proportional to the pressure. Well, actually, that is self-explanatory. Malaki yung volume, maliit yung pressure. But as the volume decreases, syempre, maliit na lang yung space. The pressure is very high. Okay? But ang volume and temperature, they are directly proportional. So if we will continue that one, eliminating this proportional sign, let's make that in equal, no? So merong lalabas na proportionality constant, K. So V is equal to K times the quantity T over P. So isolating the K constant, that would be PV over T. So therefore, if equating K all over any of the gases, that would be P1 V1 over T1 is equal to P2 V2 over T2. Okay? So yan na yung gagamitin natin. Ito na. Well, actually, there are many scientists, no, contributed to this one. Okay, yung isothermal state, yung adiabatic or isentropic, or yung kay Charles Law, yung kay Charles Law is constant pressure, if I remember it correctly. So let's just focus on this. So for isothermal condition, meaning isothermal, the temperature within the region or the surrounding is constant. So from this general equation, equals si T1 and T2. So of course, makancel yan, matitira is P1 V1 equals P2 V2. If I'm not mistaken, si Robert Boyle yung nag-contribute nito. No? Kanan siya. And the other is adiabatic or isentropic condition. So ito yung relationship. P1 V1 raised to K is equal to P2 V2 raised to K. What is an adiabatic or isentropic condition? Well, ang ibig sabihin lang yan, hindi ito siya applicable sa fluid, no? But this is sort of applicable sa thermodynamics, no? Basic mechanical engineering. So if you are mechanical engineering, you know about adiabatic and isentropic condition. The isentropic condition is that the entropy of a liquid remains constant, meaning there is no heat transfer between one, what do you call that? One region to another. No, there is no heat transfer. So if may mechanical engineering man yan nakikinig or watching this video, please correct me if I'm wrong, no, about adiabatic or isentropic condition. Kasi baka nakalimutan ko na. Okay, so anyway, the values of K, some of the values of K, ito siya, no, 1.4 for air, ammonia 1.32, and so on until sulfur dioxide, which is 1.26. So I remember nung thermodynamic subject namin, always 1.4 ginamit. So kaya pala, that is for air, no? Most of nitrogen oxide. Okay, so from that, I guess we are done showing the formulas, no, that are necessary for the examples. So let's try this problem. Calculate the density of water vapor in kilogram per cubic meter at 350 kilopascal absolute and 20 degrees Celsius if it's gas constant. Gas constant is 0.462 kilopascal cubic meter, kilogram, Kelvin. Okay, so sige daw. Let's solve this one. Okay, so syempre, density of water vapor will be using the relationship of ideal gas law, no, which is PV equals MRT. So the density is M over V, so pressure over RT. So let's solve first for the absolute temperature because 20 degrees Celsius pa man yan. Let's convert that into degree Kelvin. So that will be this one, no? 20 degrees Celsius plus 273. So obviously that would be 293 degree Kelvin. So by having the absolute temperature, let's move to this formula. So that would be this one, no? Pressure is 350. Well, actually, the problem states that it is already in absolute. Okay? So remember, absolute, no need na siya na i-convert or any sort of relationship na meron tayo. Okay, and for R naman, 0.462 kilopascal cubic meter per kilogram Kelvin. So let's try look at the units, no? Cancel si kilopascal, cancel si degree Kelvin. So obviously, yung matitira is kilogram at saka cubic meter. So therefore, by using your calculator, the density is 2.59 kilogram per cubic meter. And that is the answer. Right? Madali lang. Next example. At 90 degrees Fahrenheit and 30 psi absolute, the volume per unit weight of a certain gas was 11.4 cubic feet per pound. Determine its gas constant R and the density, oh, that's not P, no, density rho. Okay, so let's use the ideal gas law pa rin, no? So sulat mo natin yung given. That's it. Yan na yung given. Okay, so for the gas constant, again, ideal gas law yung gagamitin. Ito, PV is equal to MRT. And we will just, what do you call that, rearrange. But now, wala tayong density na given. It is being asked also. The given is the specific volume, the temperature, and the pressure, which is in absolute state. So how do you solve this one? So if you can remember sa part 1, if you've seen the part 1, the specific volume is the ratio of volume over mass. Okay? Or simply the reciprocal of the density. So for the specific volume, just have V over M. No? Specific volume is V over M. That would be, by using this relationship, that would be RT over the pressure. Okay? So I hope that is clear. No? The temperature now is 90 degrees Fahrenheit plus 460. So by using your calculator, that would be obviously 550, I guess. No? 550. So now, using this one, tanggalin na lang to. Ito na lang, no? Kine. I-rearrange ko lang yan, no? From here. So by using that one, ito na yun. Substitute lang yung mga kailangan i-substitute. So in here, this is the specific volume. Ito yung pressure. Take note, we need to convert. Okay? Because inches man siya and dapat feet. Okay? So cancel na siya. So that's why merong 12 inch to cancel. Cancel na siya. Okay? So the answer to that would be 89.54 feet per runkine. Okay? Kana siya. So the next question is for the density. So pwede ito. Kana. Using this relationship. And substitute ulit yung values. Kana. And take note for the conversion. Alright. So the density shall be 0.0877 pound per cubic foot. Okay? Or simply, again, as what I've said before, the density is just the reciprocal of the specific volume. That's it. Okay? So, i-reciprocal mo lang yan. Well, actually, if you are having this calculator, so that would be 1 over 1.14. So that would become 0.877. That is approximately equal to this. Okay, no, that's not 1.14. 11.4 rather. Yan. Tama siya. So same gina. Okay? Another example. Calculate the approximate water depth in a reservoir if an air bubble traveling upward becomes 3 times as large by volume at the surface as that at the bottom. So this problem came out. No, this is not a board problem, I guess, but rather this is a quiz ball problem. No, national stage, no, national elimination for civil engineering quiz, no, 2017, I guess, or 2018. Okay, so ganito yan. How to solve this? So suppose ito yun, reservoir, imagine. And there is a bubble that from the bottom daw until surface, lalaki siya by 3 times as large of that. So, let's see, no? Okay, so those are the bubbles. Oh, yun. Yan. Okay. So from here, this is the original bubble. There, naging 3 times larger siya sa surface area. Okay, so how do we solve for the water depth? Ito yung tinatanong, value of H. So for that, syempre, it is obvious that we need to consider 2 points having the formula P1 V1 equals P2 V2. So let's say ito yung point 1 and this is our point 2. Now, how do we solve this one? Okay, again, let me show you the formula, no? At isothermal state. Wait. Why is it isothermal yung ginamit natin? Because, sir, in the problem, there's no temperature given. Yes, that's correct, no? Technically, that's correct, but what's the main reason? Well, actually, that is reservoir. Throughout the surrounding of a liquid, same liquid lang siya. Same liquid lang siya. Syempre, most or approximately, if not equal talaga, that is same yung temperature throughout the surrounding. So that's why isothermal state. So mag-cancel lang yung temperature. Okay? So let's use this one. Okay. So what are the pressure at point 1, P1? What is the volume? V1, P2, and V2. So those are the questions, no? So ang V1 and V2, alam na natin since the problem states that from the bottom, let's say the volume is V, and to the top, naging 3 times. So that would be 3V. But how about the pressure? Yan yung question. Okay. Remember, within this formula, dapat ang pressure is in absolute state. Okay? So, i-insert ko na lang. This is for the next topic man sana. But anyway, that this is very important in this solution. Remember that absolute pressure is equal to gauge pressure plus atmospheric pressure. Okay? The atmospheric pressure is the pressure sa atmosphere. Okay? Standard niyan is 101.325 kilopascal or 14.7 PSI. So, if gusto nyong magkuha ng conversion na yan, pwede nyo namang ma-search yan sa Google. No? Okay, so yung gauge pressure, bakit gauge? Okay, bakit sir, hindi lang natin diretsyo kunin yung pressure dyan, absolute na yan? No. You cannot use absolute pressure. Dito kasi sa ilalim, there's no atmospheric pressure. And yung gauge pressure, that is based on the instrument you use sa pag-measure ng pressure below the water surface. Okay? So, instrument yan. So, that's why gauge. From the word gauge, gauge, gauge. gauge. The other one is the vacuum pressure. But sige lang, we will be discussing that throughout our lecture series for fluid mechanics. So from here, that would be sa P2. Unahin natin yung P2. 0 ang gauge and atmospheric pressure is 101.325. This is standard, not a standard. Why is it 0 yung gauge pressure? Okay, that is exposed at the atmosphere. Okay, if exposed sa atmosphere, gauge pressure are always assumed to be 0. Okay, because ang instrument again is for beneath the water surface. Hindi siya pang above. So that's why 0 siya. So P2 is just 101.325. Now, for P1, ito siya. Gamma H plus 101.325. Where did I get gamma H? This is the basic formula of pressure. Gamma means the unit weight of the liquid and the height is syempre this height. If ano yung gusto mong pressure kukunin. Okay? Yan. So plus 101.325. So therefore, ito na yan. So isunulat ko na lang yung V1 and V2. Okay? So let's solve first wala tayong unit weight, no? How to solve the unit weight? Well, of course, you cannot solve the unit weight if you don't know this one. Specific gravity of the ocean. That would be approximately 1.025 or sometimes it is 1.03. Round off lang yan, but yes, okay lang na siya. So by using that, pwede natin kunin si unit weight of the ocean by multiplying the universal water. So that would become 10.06 kilonewton per cubic meter. Now, by using this relationship, pwede na natin gamitin ito. P1 is this. Gamma is 10.06. So, gi-substitute ko lang dyan. Unknown si H. So, V1. P2 is 101.325 and 3V. Yan. So, actually, if you could see, cancel yung V. Okay? Cancel. So, transposing the terms, no, as a small algebra operation, that will become H is equal to 20.14 meters. Or gusto nyo ship solve na lang. So let's try, no? 10.06 x plus 101.325, okay, is equal to equal to 101.325 times 3. Okay, yeah, 20.14 meters. And that is the answer. Okay, so that's it, no? Okay na siguro na-discuss ko na yung ideal gas law with relative to fluid mechanics. But if you want to understand more, for another example, let me give you this one. No? For more example, merong problem dito, no? By Engineer Jobert de la Cruz, a very good friend of mine. No? We graduated together from University of Cebu. Meron din siyang YouTube channel. That would be this one. No? Engineer Jobert S. de la Cruz. Subscribe nyo na yung channel niya. Marami din siyang videos. No? Nauna siya, actually, nauna ako na-start, tapos huminto siya, nagpatuloy. So, marami na siyang video. No? Ginawa niya to for you guys, no? Para sa atin and matuto tayo lahat. Okay? So, I'll just put the link below sa YouTube channel niya para madali nyo na lang hanapin. Okay? Magandang problem to siya. No? Magandang problem. Okay? So now, thank you for watching my video. So if you like what you see, please hit the like button. And if you haven't subscribed yet, please click subscribe. And also, if you want to be notified whenever I upload another video, So just hit that bell icon there and everything will be okay. So thank you again and have a great day. God bless everyone.